Good morning. So, our second civil engineering practice on land, similar to highway engineering, is the railway engineering, railroads. There are several civil engineering activities required for a very efficient evolution of a railway track and the auxiliary units. Actually, railway started with a traction system at the early 17th century. This traction system started. Then gradually developed in 18th and by later 19th century, we had the full-fledged long railway lines capable of handling greater speeds, capable of handling larger loads with a great carriage capacity and very smooth transfer of this total load overburden comfortably to the soil. So it is a development for 3 centuries, almost 3 centuries. Railway started with the process of traction, pulling. And during the process of traction, sometimes we have to have on steep slopes a push to. So trains are there as traction or pulling trains. Similarly, push-pull trains. These push-pull trains will not be there everywhere. An additional rear engine will come and push the train up on steep slopes. Mettupalayam, Kunu, that area, certain areas there will be an engine will come at the rear part and push the train up. Double engine. Then it will leave. Then the front engine will take care of the traction. The hill temple Palani in Tamil Nadu, you have a traction system of electrical locomotive. Locomotive is not electrical, but the traction system, pulley systems can be electrified. So 3 or 4 or 5 bogies with people, a well-connected or well-held steel stranded rope, a thick steel stranded rope will pull these bogies up using a very heavy, large pulley over which these strands will be wound round, enable the bogies to reach the top. While coming down, this pulley will release gradually these strands and they comfortably come down. There will be 2 rails on which these bogies. Initially, the traction was on timber members. Timber is a highly resilient, even though it is subjected to fire attack, it is a good insulator, it is highly resilient, it can take shocks, very absorbent, shock absorber. It can take comfortably load too, provided it is properly seasoned. properly tried out. Structural timbers, they can be used. And they were being used at that time, and longitudinal members. Similarly, stone members, granite stone members, over which you will have open boxes driven by bulls, just like a bullock cart. The limitation of this system is, since the rail are weaker, you cannot take more load on them. The carrying capacity of the bogies or the boxes have to be limited. The traction capacity, the traction is being done by the bulls, so their carrying and traction capacity has to be taken into account while loading the boat. Similarly, the speed, they will be going with a small speed. So it will take more time, the traction time will be more from one point to the other. Rails are used initially for transfer of goods, transportation of goods, especially timber, log of goods from forest to the neighboring places. Then gradually the stones and the timber rails are replaced by iron rails, especially wrought iron rails. Wrought iron, there are two types of iron, cast iron and wrought iron. Wrought iron rails were common. Wrought iron rails. So you can slightly increase the speed, you can slightly increase the load, and if you can improvise the traction system too, there is a development, a significant development in the carrying capacity, right? The speed and the capability of the traction. In the later part of the 19th century, a full-fledged railway system had been established with the railway lines made of steel rails, rolled steel joist, long members of steel. So steel members are the most common component used for the railway track, railway line. The cross section will be just like the shape of an eye. It's called an eye section. There are various eye sections who have a handbook on steel, IS 800. You can see a small flange. The top portion of an eye section is called top flange. Flange at the top. Then you have a web, a vertical member known as a web or a stem. Then you have a wider flange at the bottom. So a top flange, a narrower top flange, then a constant thickness of web, then the bottom wider flange. If you want to have an analogy, you have the chess pawns used in soldiers chess. It's not actually circular. What I'm telling is it will have the smaller, then a vertical piece, then a bigger base. Usually the edges of the flanges will be curved. It will be just like holding like this. Then just an eye section like this. Then it comes like this. Then it goes like this. It holds tons of load. That is the carrying capacity of steel. Rolled steel joist, RSJ joist, having definite meters length, starting from 3 meter, 4 meter, 5 meter, over which you have the bogies. So the traction system, since the carrying element strength is considerable, its versatility of transfer of load is considerable, its character known as the ductility, high tensile strength, vibration resistance. Vibration resistance is the most important thing as far as train traffic is concerned. Most of the railway stations you see, more steel structures will be there. The reason for that is steel are capable of taking more vibrations. And vibration is a very common cause in railway lines and adjacent areas. But one major disadvantage of steel tracks, now, sensitive to temperature. They're sensitive, susceptible to temperature. So provision has to be made for the expansion of these members. You cannot connect them together like this. If you start connecting steel members like this, while expanding they will go like this. Expansion they have to go. In compression they will go like this. But while expansion, these two members goes like this. Just imagine that the train is going above, and if they do like this, that is all. So you have to facilitate. You have to facilitate corresponding expansion joints. That there should be a literal gap, knowing the coefficient of linear expansion of steel, the maximum peak temperature, giving a factor of safety, provide one gap. So when you provide this gap between these rails, the wheels of the bogies will be coming. Just see, suppose it's like this, it will go continuously, no problem. But like this, the wheels will come, enter a dip, again come back, another dip. Whenever the length of the that joist of the member is over, you will see. That is why you hear a sound whenever these wheels enter the gap of the railways. People mimic that sound. Not only that, there will be heavy load, impact load, by which there is provision. There will be these end of the rails often is subjected to wearing of the rails, because they are subjected to impact loads, shock loads. So these members, these two rails will be connected together. They have to be connected together. So now I shift to this. This is the plan. This is the elevation or the longitudinal view. So these two members, we have two, they will be sandwiched between two steel plates, a thick steel plates known as the fish plate. So fish plates connect two rails. These two members are connected by a fish plate. They'll be bolted or welded properly, facilitating this expansion. That expansion has to be facilitated. They'll be those are all designed. You will be designing the fish plate, you will be designing nuts and bolts, you will be designing even the rolled steel joist, its section. All those things will be the depth. You have to go deep. I'm just telling the superficial thing, just to give a insight towards the topic. That is all. So fish plates, they connect. So steel rails are common nowadays, on which you have history. If you go back to history, the traction was by coal, steam engines, then diesel driven, petroleum, diesel driven. Now you have electric trains. So the latest electric trains. Time will come when it will be an electric train with a pilot or without a pilot. Pilotless trains are possible, as you have pilotless cars, driverless cars, or a hybrid. If you want a driver, you can have. Similarly, you can have. Everything is automated also. You have very smart engineering railway system. We'll see gradually to that. God bless. Thank you.